Hello students, in previous class already we discussed the aldol condensation, that is very important naming reaction. So in today's class we will discuss about the cross aldol condensation reaction. Okay students, we just revise the aldol condensation, then we will go towards the cross aldol condensation. So in aldol condensation what we are going to see? So in aldol condensation students, so there I am using the some aldehyde and ketone which contain the alpha hydrogen atom. Only that aldehyde and ketone undergoes aldol condensation reaction. So students, that reaction we can carry in presence of dilute NaOH or dilute KOH. So in cross aldol condensation also we can use the same method, but here we can use the two different aldehyde or two different ketone groups. Okay, so for example in aldol condensation we are going to using the 2-acetaldehyde molecule. Okay, then we will carry the reaction and we will get the aldol. But students, in cross aldol condensation we will take on one acetaldehyde molecule and one acetone molecules. Okay, so already we discussed the mechanism in details in previous class. If you want to see the mechanism, you can check. Okay, in Dropbox already I given the video, you can check that. Okay students, so in aldol condensation already we discussed that reaction. Now we see the in details about the cross aldol condensation reaction. Okay students, so in cross, why we can see it is on cross? Because here we can using the two different aldehyde and ketone groups. Here I am using the acetone molecule. Okay, CH3 C double bond O CH3. This is what acetone, and here I am using the acetaldehyde CH3 C double bond O H. In aldol condensation, what we are doing? We can using the same molecule like acetone plus acetone or acetaldehyde plus acetaldehyde. Then only aldol condensation will carry. But in cross, we can using two different components. Okay, so the remaining reaction condition will be the same. One acetone and acetaldehyde molecule will react in presence of dilute NaOH. So see the reaction students here. So what we will doing in mechanism? So already we discussed that whatever first molecule you can take on, so that first molecule will react with NaOH. So this is NaOH. So in that OH minus it acts as a nucleophile. So that nucleophile will react with acetone molecule, and then what they will do, it can form the carbanion, means nucleophiles. Okay, so already we discussed that mechanism. It can form the nucleophile, and this nucleophile will attack on carbonyl carbon of second molecule of acetaldehyde. So here they will attack. Okay, and then we will get one intermediates. Again in third step we will do the protonation and we will get this compound, that is a 3-hydroxy 3-methyl butanol. Okay students, just I will give some tricks how we can remember this reaction. Already discussed the mechanism. Just see here acetone, and here I am taking the acetaldehyde molecules. So from this acetaldehyde, CH3 it contains the 3 hydrogen. One hydrogen will going to be attached to this oxygen. Okay, now this converting to the OH. Now what remains student here? CH2 C double bond OH. This whole group going to get attached to this carbon. Okay, so we will get this structure 3-hydroxy 3-methyl butanol. Now clear students, how we get this structure? Simply you can remember like this, whatever second molecule will be there. So from that second molecule, so this hydrogen is very acylic hydrogens. They can you should attach to this oxygen, and simply we will get this 3-hydroxy 3-methyl butanol. So in details you can check in mechanism. Okay, so already we discussed in mechanism also. So we will discuss the second example here. I am taken the benzaldehyde molecule, and here another example is acetophenone. Benzaldehyde, benzene ring containing C double bond OH. So this is what? Benzaldehyde, and this is acetophenone. Means it is a ketone. Benzene ring C double bond O CH3. This is acetophenone. So student, here also same mechanism we can apply. So from this CH3, one hydrogen attached to this oxygen. Now it convert into the OH, and remaining group CH2 C double bond O, and this benzene ring going to attach to this carbon, and simply here we will get this structure benzene ring, then this CH, then OH, then this CH2 C double bond O, C double bond O, and this benzene ring. Okay, so we will get this structure. Again students, we can heat. After heating, what happens here? So it can loses the water molecule. It undergoes dehydration. Okay, so how water molecule will remove? So obviously this OH will remove, and one hydrogen from this CH2. Okay students, this OH and this H, H2 will remove. Now double bond will come, CH double bond CH, remaining structure as it is. Benzene ring, CH double bond CH, C double bond O. This another benzene ring. We can say it is a 1,3-diphenyl-pro-2-en-1-ONE. How we can give the numbering? So just start the numbering from here. This is the first carbon, second, third. On third carbon, on first and third carbon, 2 phenyl ring is there. Okay, so this is your first carbon. In that first carbon, this benzene ring is attached, and third carbon, another benzene ring is attached. So you can see this is a 1,3-diphenyl. Okay, so diphenyl, and then this 3 carbon, 1, 2, 3 means this is a 3 carbon, but double bond is there. We can see this is a pro-2-en, because on second carbon double bond is there, and on first carbon ketone group is there. We can see this is a 1-ONE. Now clear, students, all of you? So you can check the mechanism of this reaction in aldol condensation reaction. Already in details I am discussing the mechanism. You can check that. So this is very important reaction in your competitive exam. So thank you so much for watching this video.